I hope you are all smiles because you should have just finished a quiz, and I hope you did well on it, and the grades are good and that you're understanding everything. So that's why I'm hoping we're all smiles and ready to roll again today. We are moving right along to proportions. We're still dealing with ratios because we have, sorry, it's blurry. Comparing two numbers. This time we're going to start comparing two ratios though. And we're trying to determine, are they equal? And a lot of students have a hard time because they look at these and they all look different. But even though they look different, they are all equal. And some people have a really hard time with that. Just because they look different doesn't mean their value is different. We practiced earlier in the week that if we simplify this, we divide by 5. If we divide both of these by 5, we get 1 over 2, or 1/2, or 1 to 2. If we simplify here, we can divide both of these by 3, and we're going to get 1/2, or 1 to 2. If we simplify here, we're going to divide by 7. We're still going to get 1/2, or 1 to 2. So actually all of these are equal even though they look different. So we need to kind of explore and think about today, how can I determine if two ratios are equal even when they look different? So there's lots of different ways to do that, but we're going to try to, we'll go over several different ways, but then there's one way that I want you to mainly focus on because it'll help us next week. One way to do it is some students like to look at these as division, and they would do 5 divided by 10 and get 0.5, and 1 divided by 2 and get 0.5. Well, 0.5 and 0.5 are equal, so they would say, yes, these two ratios are equal. Some people like to think about it and simplify by dividing one fraction and see if it equals the other. Some people like to say, well, I can divide both of these two by 5, and this is 1/2. So since this is really 1/2 and this is 1/2, then yes, these are still equal. But the way I want you to focus on is looking at diagonals, because that's going to help us, like I said, later next week when we start solving proportions, when we have missing values in here. So if we look at our diagonals, I'm going to look at from one corner to the other corner. I think in 6th grade y'all may have used the phrase cross multiply. But if I look at this diagonal, I get 10. And if I look at this diagonal, I get 10. And since both of these numbers are equal, then yes, my proportion is equal. So today is going to be just determining, are my two proportions equal or are they not equal? So the way, I'm not going to go through and divide all these out or try to simplify fractions. I'm going to stick with the diagonal method. So I'm going to look at both diagonals. And most of these numbers are a little bit bigger than we can do in our head, so a calculator's fine. If I do 5 times 24, I get 120. And then I multiply this diagonal. I've got 15 times 8. 15 times 8 gives me 120. So they do not look the same, but yes, they are indeed equal. So my answer would be yes to this one, that it is proportional. And remember, proportional means equal. Okay, again, we've got to determine proportional or not, which you may be able to do this in your head, or some of you may be like, oh gracious, I just got up. I just did well on my quiz, so I don't want to sit and think about this multiplication. So I'm going to be on the lazy side and use the calculator. If you do, 3 times 9 is 27, and then 4 times 8, 32. We look at this diagonal and then this diagonal. Either way, it doesn't really matter the order you do it in as long as you're going corner to corner. But this would be, no, they are not proportional because these two numbers did not come out equal. And if you wanted to check it with one of the other methods that we did a while ago, like 3 divided by 8, you don't have to do this. I'm just proving it another way. That's 0.375. And if I did 4 divided by 9, that's 0.4, and it keeps going, so I put bar notation so you know they're not equal. But again, I'd rather you focus on this diagonal method at the moment. So we're trying to determine proportional or not, which I put equal or not equal, but that's the same thing as proportional. So again, I'm going to look at my diagonal. 5 times 24. I might have done this one twice. I don't know. 120. And 7 times 16. 112. So my answer for this one is going to be no as well. No, it is not equal. All right, one last one. Maybe this will be the shortest video yet. Look at your diagonals. 16 times 5. We got an 80. And most of you probably can do 20 times 4 in your head and get 80. But we'll punch it in just because we're in the habit of punching it in. So then that's going to be yes, they are equal. So all you have to do today is determine, are they equal or not equal? So your answer is a yes or a no. So I hope this is easy, and happy Thursday, and I will talk to you again Friday.